Let's start off first of all with footings. Now, footings is the term that's given to the walling that sits between the foundation and the damp-proof course. Okay, the whole thing isn't the footings. The whole thing, the work below finished floor level, is collectively and commonly referred to as substructure. Okay, so everything below finished floor level is substructure in its collective title, and everything above finished floor level, DPC, traditionally is known as superstructure. So substructure below, superstructure above as collective terms. Okay, but when we look at footings, i.e. the bit that us bricklayers will really get involved with, and I'm going to reference most of this detailing to the construction of residential buildings. Okay, what we'd be looking at is a cavity wall, although we can get the same footing outcome with a solid block, a trench block, but a cavity wall traditionally 90% of what you build will be 100 millimetres of cavity, 100 millimetres of blockwork and 100 millimetres of brickwork, actually 102.5, but we're not going to quibble, with an overall dimension therefore of 300 millimetres. That footing, whether it be brick or block, will be built on a foundation, usually excavated for residential properties to a width of 600 millimetres, and what we're really looking for is for that footing to be sat directly in the middle of that foundation, that 600 millimetre foundation, so we have an even projection both sides and the load is transferred from the wall in through the foundation equally to both sides, covering as wide an area as possible. As you can see, there's tie irons would still be built in depending on the depth, and what we would have to do before we backfilled this particular footing and these trenches, we would have to fill within this cavity here in order to stop the two walls being pushed together. We'd have to fill in with a lean mixed concrete, okay, up to ground level, and you'll see on the next slide what that looks like when we get up there. We don't have the same issue on the trench blocks. They're solid. There is no cavity within them until just below ground level, where we would leave off the trench blocks and then start to build two independent leaves, the brickwork and the blockwork, as is traditional, with the cavity in the middle. Okay. If we look at the ground floor construction, two primary types that are commonly used now, but one thing I will say is you can see in this particular one where the cavity has now been built up, you'll notice that the blockwork on the outside leaf, the leaf that's going to be brickwork, has been stopped off lower than the finished floor level, than the damp-proof course, and that's to allow us to start our brickwork just below ground level, so we can sort out our bonding, we can make sure everything's nice and level, so as the facing brickwork is visible as it comes out the ground, our bond is correct, joint sizes are the right size, and we know we're going to be, you know, have an aesthetically pleasing look. The blockwork on the inside has gone up to damp-proof course, and you can see on the inside there we've got a hardcore base that would have been hardcore backfilled all the way down through that trench as well. On top of that hardcore base, we would have some sand blinding, we would have a damp-proof membrane, we would have insulation, and then we would have an oversized slab concrete, and then some type of floor finishing on top of that. So this solid ground floor is a floor that is in direct contact with the ground below it. Very common nowadays is a slightly different type of flooring, which is block and beam. As you can see, the walling on the inside has been built up to damp-proof just the same. You can see the damp-proof course actually sat just below those beams, and then beams are laid horizontally from one side of a building or a room to another at equal spacings, and then blocks just deposited in, just sat in dry in between those beams, and then some type of floor finish would be placed on top of those. You'll notice that we have a hollow underneath this block and beam floor, and you'll see this air brick that is part of the construction that allows us to ventilate that underfloor space, and we'll just have a look at a little bit more detail in that in just a minute. So we've got a solid ground floor and a hollow ground floor. Years ago that would have been with timber, still is in some places, they still do a timber floor, but more often than not it's block and beam. Okay. If you can look at here, there's two detailings of different types of ground floor structure. As you can see, we've got a foundation here, we've got the cavity walls running up with the blockwork finishing off slightly earlier and moving into brickwork. The cavity has been filled, and this is what's known as a sectional drawing, and we use British Standard 1192 as the basis for identification of materials. So we know that within British Standard 1192, two 45-degree horizontal lines close to each other, a gap and then two more, denote brickwork. Okay, I haven't got to write brickwork on there, I know that that's what they mean. The 60-degree lines here within the yellow denote hardcore. Okay, so what we're able to do is to look at a sectional drawing and identify the materials and the type of structure. You won't always see this on elevations and plans, it's a sectional detail that you would need to go to. And quite often the working drawings, which include the sectional details, will be accompanied by a raft of written information. That's called the specification. So all of this writing would quite often sit within the specification. It would declutter the drawings, and we'd have this document over there that we could refer to, known as the specification. That supports the working drawings of plans, including the sectional detail that we have. Okay. I talked a little bit earlier about just finishing the external leaf of the blockwork just below ground level, and the reason for that is so that we can sort out our brickwork bonding. We can chase that out, we can work out how big the joints are going to be. In an ideal world, the bricks would be 215 millimetres and every joint would be 10, but we don't often work on an ideal world. Sizes are often dictated by other things than brick dimensions. So we may end up with a length of walling that doesn't specifically work ideally at 215 plus 10 for a joint, and we may have to put cuts in there. That's known as broken bond, and where we have broken bond, wherever possible, we want to chase that out below ground level and site it below an opening, ideally a door. If not a door, a window. It just means that there's less of it as you go all the way up the wall. It would stop, as you can see in this. When we're building with broken bond, nothing ever smaller than a half. Okay, on stretcher bond, when we're in the solid wallings, the English and the Flemish and the garden walls, then clearly there is the requirement for a quarter or a queen closer. But on stretcher bond, we should never have anything less than a half. So if we've got a slight variation on the overall dimension and we need to put broken bond in, it would look something similar to this. And as you notice, this in this particular instance is placed below a window, ideally a door if you can. Okay. We noticed the air brick a little bit earlier on the block and beam flooring, and this would be the same with block and beam or a suspended timber floor. We need to ventilate that underfloor void, that hollow space, and as you can see, the air brick in the external wall, and then we have a liner that goes through the cavity and takes the air and allows the underfloor space to be ventilated to prevent the build-up of obnoxious gases, etc. You'll also notice above the air brick here, because we've now bridged the cavity with something, we've put in a cavity tray. We'll talk a little bit more about that later on when we come on to lintels, but wherever we bridge a cavity, we really want to be thinking about putting in a cavity tray. So as you can see, air brick liner ventilating that underfloor space on a suspended ground floor. Years ago, when cavity walls were first introduced, as bricklayers we would build up our cavity walling back in the day with 2 leaves of brickwork actually. More recently, well the last 40 odd years, with a block on the internal leaf and a brick on the external leaf as a usual minimum requirement. But the insulation was pumped in afterwards quite often. And what we really want to do was to stop the build-up of mortar in a cavity as we're laying bricks. You know, it's like you lay your brick. If you don't get the mortar, the excess mortar scraped away from the back of the brickwork or the blockwork, it's going to cause a blockage within the cavity. It's either going to drop down there, it's going to bridge times, etc. So what we used to build in were core holes, so holes at ground level. So at the end of every day's work, you could knock all the mortar off times, etc., and the walling that you just built that day. It would drop down to the ground, and you could clean it out. And at the end of the job, you'd refill these. Sort of went away with the introduction of cavity wall insulation that we built in as walling proceeded. But there is a trend again moving towards insulation being pumped in at a later stage. So just bear in mind that there is such a thing as core holes. This is what they are. They allow you to keep the cavity clean at the end of every day. An alternative method to that is just to, on the top of every layer of tie irons, as you get up to each layer, put a board. Okay, and as you can see, as the mortar is cut off, it will drop off the border, and it should ideally just stay on your trowel and return to your mortar board. But if there are any drop-ins, they're going to drop into your board that you can lift up, clean off, and carry on working. Again, it just stops mortar bridging the cavity, whether that's on top of insulation backs, on top of tines, or a build-up at ground level from, so that it's above damp-proof course and would cause rising damp. One of the primary purposes of a cavity wall is to stop, the ingress of moisture from the outside to the inside. And if we bridge the cavity, clearly we've disadvantaged that. So talked about cavity patterns, we've talked about coring holes. Obviously we're all looking at this as a damp-proof course, and there are three types of damp-proof course. There's flexible, there's semi-rigid, and there's rigid. The most common that we'll be using is a PVC, such as this. Damp-proof course, minimum of 150 millimetres above ground level. It can be higher, can't be any lower, so ground level, and then at least 2 courses of brickwork between the finished ground level. And think on if you're going to be putting slabs or path down, make sure you don't make that gap between the finished ground level and the damp-proof course. One of the things that's not showing correctly on this particular photo, it doesn't look like the damp-proof course was bedded in. It needs to be bedded on a nice solid 5mm mortar bed, and then with a 5mm bed on top of it in order to then pick up the brickwork. Again, going back, they used to quite often make a feature and have a slightly wider joint with a weather-struck finish around the damp-proof course, just for aesthetic value really. Nowadays it tends to be, it's hidden within a 10mm joint. So the damp-proof course does need to be bedded, and as I said, minimum 150mm. One of the disadvantages of a damp-proof course, and not so much in residential buildings but in freestanding walls, is there is a complete break really between the walling in the substructure and the walling in the superstructure. It's a bit of plastic that was shoved right between the two, and there's a loss of bond. So what you can do is you can build in a damp-proof course with 2 courses of engineering bricks. And the reason for 2 courses of engineering bricks is you can't really damp-proof the joint, and so for the moisture to bridge that damp-proof course, it has to go up the perp joint, across the bed joint, and up the perp joint again. It just gives it a significant distance that it has to travel. Quite often people will use a damp-proof course and a PVC, a rigid damp-proof course, engineering bricks and a PVC damp-proof course in the same thing. In that particular instance, the engineering bricks tend to be purely for decoration because you're getting what you want from the PVC. There is also a semi-rigid classification of damp-proof courses and damp-proof membranes, and something like mastic asphalt, more of a specialist application, quite often used in forms of tanking, but as you can see, a damp-proof is being fixed in place there, or positioned in place, lapping up the brickwork and over. So the three classifications of damp-proof course are flexible, semi-rigid and rigid, and there's an example of each. Okay, so we've got onto our superstructure. Again, very basic recap here. Once we start on our brickwork, on the external leaf, we build our corners, we rack back, but quite often, again, you'll go on site and bricklayers will be using profiles so that they can take torque course for course, so you won't often see the racking back element there. They're just fixing their profiles in place and lining in full courses. Okay, as you know from the work we do in our practical sessions, smaller corners, you know, you're a lot quicker, you're a lot more accurate laying to a line than you will be with a level. So just focusing on getting small corners up and the line on as quickly as possible. And if you are working with bricklayers that use profiles, that's what they look like, and that's how they're fixed in place. Okay. When we are building in intermediate, which is running in, lining in, okay, then what we're looking to do between our two corners, the lines on, whether that's profiles or that's corners, we want to make sure that that line stays very horizontal, nice and level. And on a really long wall, what you will want to do is to place a tingle plate at an intermediate point to take any sag out of the line if you can't pull it tight enough. But also the same on a really windy day, exposed site. Again, the constant movement of that line is going to make sure that, well, it will disadvantage you again. So what we're looking to do is to get tingle plates when we're lining in and filling in with an intermediate point, and that would also become a plumb point if I was to have a tingle plate or at that particular stage. Okay, bricks obviously will be the usual cavity wall external leaf. Well, that can be blockwork and rendered. Internally we use blockwork. This is an aerated block. Okay, I like to use the sort of idea of a Yorkie bar or an aero bar. You know, Yorkie bar, something nice and really solid, an aero bar full of holes. This is what this is. Trapped air is a really good insulator, and so whilst we can use, you know, an aerated block, lightweight block that's full of holes on the superstructure, because of those, because it's full of holes, we shouldn't really be using it. Well, we can't use it within the ground. So a nice lightweight insulating block or a breeze block, again, that would provide us with sufficient thermal insulation to make the cavity construction acceptable to current standards and regulations. Both of these materials, certainly the aerated one, normally we'd be cutting in hammer and bolster, just obviously wearing the appropriate PPE, and with the lightweight aerated blocks you can use a masonry saw. Okay, and again, both adequate. There's a number of sites now where cuts will come pre-cut for you, but if you are going to use any of these, again, as I said, wear the appropriate PPE, goggles, gloves. If we look at a cavity walling, in here, as we said, we know it's brickwork on the outside, blockwork on the inside, with an insulation fill. Insulation is either partial fill or full fill. In this particular case, what we're looking at is a full fill insulation, which means it's 100 millimeters wide. If you've got a wider cavity, it would be a wider insulation. Okay, and there's a couple of types, lots of different makes, but a couple of types of insulation. We've got the rock wool, as in this particular case. You'll notice also that the insulation is of itself bonded, so it's not stacked one on top of the other. It's lapped over halfway and sits on itself and on the tie irons, and we'll talk a little bit more about tie iron spacings in a moment. So that's the full fill insulation, and on this particular slide what we can see is the brickwork the insulation but an air gap also, okay, and blockwork. You'll notice that the insulation is sat back against the blockwork and held in position with this retaining clip, okay, so which is clipped onto the tie lines. Now when you're building your cavity walling, if you're building with full fill insulation, you can build either leaf first. You can build brickwork or you can build blockwork. It's down to you. When you're building with partial fill, then clearly you need to build the blockwork first so you can fix your insulation back against that and then bring the brickwork up. It is recommended with blockwork that you don't build more than 6 in one day, 6 courses that is in one day, because as you get too high, the weight of the wall in itself will cause the lower joints to buckle before the hardening process has started. So as you can see, a partial fill cavity there, and if I just go back, we can see the full fill. So you can see the difference between the two there. Okay, and you can see the tines, and we'll just talk a little bit more about the tines on this particular one. Tines come in different lengths to suit the width of the cavity, but whatever the width of the cavity, the amount of tie iron that is bedded into each leaf should be a minimum of 50 millimeters. Okay, so you can't use a cavity built for or made for a 100 millimeter cavity on a cavity that you build 150. There wouldn't be enough bedded into each of the leaves. So 50 millimeters bedded into the brickwork, 50 millimeters bedded into the blockwork on the inner leaf. Okay, whilst we're also stuck with cavities, and again this is for a traditional 100 millimeter cavity wall. Horizontally, tines should be no further apart than 900 millimeters. You can place them nearer, but they shouldn't be any further apart than 900 millimeters. If you're going up to 150 millimeter cavity width, that drops down to 750 millimeters on a horizontal basis. And vertically, there should be no more than 6 courses of bricks, 450 millimeters, and the same as 2 courses of blocks. Okay, and what you will position the tines in on the main bulk of the walling, they will be positioned in a diagonal pattern, diamond. So you'll have the 2 up here, across here they would again be intermediate, and then in the course below here they would replicate this particular course. So tines horizontally in the main bulk of walling, 900 millimeters. 400 millimeters vertically, and up an opening or stopped end, tie iron should be, so we've got a window, tines should be bedded every course of blocks if it's blocks on the inner leaf. Okay, it does say within the regulations every 300. Well, if you're building with blocks, that's every 225 millimeters is all you'll be able to get, and within 225 millimeters of the opening. So as you can see, tines would be every course of blocks and within 225 millimeters. That means you will have to cut the insulation at that particular opening in order to slide the tie, or to slide it over the tie, but that's the requirement and that's what you'll be doing. Okay. If we look here as well, I've included the one only because you're likely to come across it when you do maintenance and repair, but the common procedure now for building up an opening or a reveal is that the blockwork and the brickwork don't return into each other. They are left open and you place in a plastic cavity liner. This is a bit of PVC with insulation tacked into the back that drops into the cavity, and the cavity doesn't return back round. Here you'll see in this older photo where the blockwork was returned back round into the brickwork with a small piece of insulation laid vertically in that gap, as well as a damp-proof membrane. Okay, you're going to come across that when you're changing windows, if you do alterations to window size, door size, etc. You'll come across closed cavities, but in the traditional and modern method now is to leave the 2 reveals disconnected and place in that PVC and insulated cavity closer. Okay. You'll also notice on the top here on this photo, just whilst we're here, we'll talk about it a little bit more in a minute, the damp-proof tray that sits on top of a lintel. Okay, wherever again we close the cavity, we need to make sure water is being shedded or moisture is being shedded to the outside. Okay. Cavity lintels, there's a raft of different types. The one main criteria that you need to be mindful of is, well, a couple actually, is that they're the correct width, so 300mm cavity and a 350mm cavity. Overall dimensions, you're going to need different size lintels. And also length. When you're working out the length of a lintel, for steel lintels, the minimum bearing, the minimum distance that a lintel should sit on each end of the opening is 150mm. So if you've got, a 1.5 metre opening, you're going to need a lintel that's at least 1.8 metres long, so that there is, that's 150mm of bearing at each end. Okay. Now on top of these, also when we bed them in place, you'll see on the next picture, because we're closing off the cavity, any moisture that then gets into the cavity through the brickwork, penetrating into, right through into the cavity, would come down, and we want to force it to the outside. So we build in a damp-proof tray, okay? And as you can see clearly here, a damp-proof tray sits within the blockwork joint on the inner leaf, is angled down and pushes water or moisture to the outside, sitting directly on top of the lintel. You'll see at the end here, it's lapped up and closed off. You can buy end closers, or you can fold up the end of the damp-proof tray, but again, that just stops excess moisture travelling along to the end of the lintel and then continuing its journey down the cavity. What we want to do is to force it through here, and what you're looking at here in this perp joint, okay, is a weep hole, okay, and they look like so, okay. Again, just something that would fit in the perp joint. It allows the moisture within the cavity forced out through that damp tray to then come through a perp joint and pushed to the outside, okay, and then drained away. Okay, so they are weep holes. Maximum distance apart on a lintel is 450mm, and they should cover the full length of the lintel, including over the bearing. Okay, so make sure weep holes are in place on top of the cavity tray, directly on top of the cavity tray, so that any moisture is forced to the outside. Okay, and as you can see here, and maybe not see it quite clearly enough, the weep holes here, and you can see it here. So a soldier course, this is quite standard feature above an opening, sat directly on top of the lintel. You'd have the cavity tray then sat on top of that with the weep holes again forcing moisture. And that cavity tray requirement is anywhere where we close off a cavity. We saw it on the air brick earlier. We're closing off the cavity, we're bridging it. And other areas where we do similar are things like if we're building in a meter box, okay, then we're bridging that cavity. We would need to put something in order to force the moisture that gets into the cavity out. And wherever we're using a damp tray, we want to use weep holes. Okay. If we look at joint finish, okay, a significant majority of what you're going to build is going to be finished off with a half round joint, okay, and we use a jointing iron, multiple types out there, to create this concave finish. We're actually polishing in a mortar. Slightly difference between pointing and jointing. With a joint finish, we're actually just going to use the mortar that was already between the two bricks when we've laid them in order to provide that nice finish. So we polish in a half round joint. For pointing, it means we have to add more. So we'd lay the bricks and then we'd have to add something else to it. So weather struck and cut is a type of pointing. Weather struck, which is just this particular angled finish here, so is a joint finish, because obviously we lay the brick. All we need to do is to run our pointing trowel along the joint in order to form that particular angle. But a weatherstruck and cut joint, we'd be adding a bit more mortar on because it overlaps in the top of the brick. So joint finishes, nice flush joint. Okay, quite often you'll see, certainly with handmade bricks and those properties that are, you know, a little bit older. Half round joint, 80% of what you're going to be doing, 90% of what you're going to be doing. Raked or squared recessed, again, if you're going to be raking out a joint, you want to be using a really dense solid brick that's relatively waterproof in of itself, because you're giving the weather an awful lot of a start there. Or on internal brickwork, you'll see raked and recessed finish is quite effective, and aesthetically it's nice. One of the things that quite often comes up, although I probably haven't used one myself for many years, but just be aware that, like if we have a gauge lat, okay, if you're not using your tape measure and you're using a gauge lat to maintain your bond, so increments marked on a bit of wood of 75mm or whatever your gauge is for a particular job. We also have a story rod that marks off key heights from the datum, normally finished floor level, and so there would be the top of the skirt and the top of the dado rail, top of the window opening for the lintel, etc. So you can take this around your different openings and just check it quite easily that everything is finishing at an appropriate level. Okay, as I say, tape measures tend to be used far more, and of course we've got electronic means now, laser levels, etc. But somebody might throw a question at you about the story rod, so I just thought we should just pick up on that. Okay, what we're looking also to do is to ensure that we protect brickwork, Hessian. Okay, protecting the wall is something that we would want to do when there is a risk of freshly laid brickwork being damaged, or either from rain or from the frost, and so we would cover that. One of the things that happens when brickwork gets excessively wet, and certainly if there's an impurity either within the sand or the brick contained within it, is you'll get this white powdery substance that will start coming out of the brick. Okay, and that's called efflorescence, and that is from the salt within either the sand or the bricks themselves when everything was excessively wet, coming out as that walling dries out. It's not overly harmful. You'll just need to keep, in warm weather, just keep wetting the wall down so that it's got to dry out, and as it keeps drying out and repeatedly dries out, it brings the efflorescence with them. Eventually it will disappear. Okay, but you'll quite often see that white powder, and that's where people haven't really protected their brickwork in those wetter months and days. Okay, and getting near to the end now. One of the things, again, you'll quite often see on walling, and something that we're likely to be questioned on, is a thing called banding. Okay, where you can see different coloured bricks, forming. As you can see here, hopefully it comes across well enough, and certainly most definitely here. These are, in both instances, this and this the same brick, and all of these are the same brick. They're not meant to be that multicoloured. It's just they've come from different batches. They were fired through the kiln at different times, and within that process what you end up with is bricks that are slightly discoloured from each other, but also potentially slightly different sizes. Okay, so when you have a load of bricks delivered on site, as you're stacking out, what you should be doing is taking from 3 sets of bricks, or 3 stacks of bricks at a time, to load out a length of a wall to stop this patching, this banding as it's called, from happening. With regards to size, it's really important that you check the size, because if you have a load of bricks delivered and they take you halfway up your house, and then you have another load of bricks and they take you another half away, what we're looking for is for the joints to try and maintain the same size. There is a British standard test that you can carry out for the size of a brick, and that is take 24 bricks at random from the load that's been delivered, lay them end to end, and they should equal 24 times 215mm. Okay, there is a British standard tolerance of plus or minus 75mm, so just be aware that there's a difference in brick size permitted of plus or minus 3mm per brick, which can be quite significant if you set out with a reasonable size joint on the first elevation, and then you've got a different size brick, same brick but just a different size as you're moving up. So just be mindful of that brick dimension test, and be mindful of this banding and the requirement to select your bricks as you're stacking out from 3 separate packs as they're